Oh, thanks for the introduction. I mean, this is about a sort of dream and monster that I had to manage every day. How many of you is doing incident response here, manage log? Raise your hand. Okay, I see painful faces here, so what's the problem? I mean, oh, whoa, I went to the right one. So every morning you wake up, you go in front of your CM. If your company have a lot of money, you use Splunk. If they don't, you use ALK or other solution. And what are you doing? You have a malware, someone is raising an incident, and it's painful because you're dealing with your manager, you're dealing with your director, and there's never enough money. You never have enough log. The storage is growing, the company is growing, but the solution is not linearly growing with you. So you go to buy some license, but then all the entire of your infrastructure is failing because you need to be bigger and you don't have enough connection and you don't have enough storage. Every time you finish in an incident, you have push from your management about the two processes that you have to follow, the containment action to understand where the incident is coming from. But then you have the forensic investigation, and I mean, we are nerd people. We don't like to speak with other people most of the time. And no, you have to raise a ticket somewhere, or you need to speak with your IT department. Size the laptop, do the forensic, because the log that you are getting in-house, they're not enough. In the moment that you see an indicator of compromise on your system, you have your log, you run your query, and it's not enough. You want to see another log that you never onboarded. And you can do that. And everything became a question mark. And here is when the story started. I was in this pain since years. And I started to take a look at IPFS. And PFS is pretty new. I mean, we don't run it in prod. We only play with it at the moment. And I started to try to understand what I really want from a log. Because it's most of the time granted as an idea. You have a log, you have a timestamp, and that's it. If you ask the people that work in our industry, most of them, they never tried to spend time to understand what is the expectation from the log. And practically what I was thinking about is that I don't want a log to be copied over the network. So in big corporation where I'm used to spend my time, all this log, they need to move from all the endpoint, from all the server, from all your cloud provider, and they need to arrive to a central location. And at that point, you have multiple copies of the log, and they're expensive to maintain, they're expensive to read, and you have a scalability problem. Because if you have 20, 50, 100,000 devices, and you have a central log collection, that's a scale that is not simple to maintain. I would like also to have all the file organized as a file system, instead of having a stream of log where I had to spend time between an incident and another to create the proper query, to create the proper playbook, to split all this data inside a logic. I would like to access them as I access file log on Linux. And I can grab them and I can search through them on a single machine in the moment that I had the indicator of it. History. How every time I'm watching some log, you get some vulnerability. You don't know if the log is trustable or not. It's streamed. They have different format. How can I be sure to access the log? Any one of you have ever had an incident where the laptop got reinstalled by the IT and you lost it? You don't have any more indicator. You lost the next conference where you present your malware analysis. You can't. They reinstall the laptop. And I want them, the log, to be forensic ready. Is any one of you dealing with legal department time to time? Or you can raise your hands down there. When you deal with them, it's pretty impossible to explain that you have a copy of something and there is a process somewhere. They want a block, they want a drive, they want something that can be used in a legal action. And all the solution today for log collection, they really don't do that. They require a lot of explanation. Now, I spent a lot of time, and I was presenting in the past about a lot of solutions that are endpoint ready. Think about OS query, any other things that stay on top. but they're painful as well, because in the moment that you have to convince IT to install another agent, or you have to convince your entire SOC or CSIRT to have another tool to maintain on top of your, when they have spent years to build the playbook and the knowledge to use all the tools that they already have. You don't want to introduce another one. So, what you want from log, I try to describe it here. I want comparability from log. I want the log that are able to be compared one to another. I want accessibility to the log. That is important. If I need a log, I need it now, and I need it during the investigation. I need to contain the breakout of any malicious activity. I want to be able to create inference and baseline both across my endpoint or server, but also across all the fleet in my corporate or, I don't know, university environment. I don't want to have a single source of log. I want to be able that if the laptop disappears or the server disappears, I want to be able to have a copy somewhere. I want to do drill down, hash, be able to compare my IOC on demand. In the moment that I have an IOC for something, I want to know who contains it across my fleet, whatever is the system. And ownership. Ownership is essential. You need to point your finger to someone and say, this is your machine. Because I cannot go to my management and say, sorry guys, we have an infection, I don't know where, I don't know who. But we have it. It could work a couple of times, and then they start to make questions. So you need to know who owns that host. And it's like 10 years I'm working with Splunk. I saw Splunk people, I love you. Time to time, people ship log, and the log are so many that you see the indicator, but you don't have the IP. Or if you have the IP, you don't know if the IP belongs to the person because, wait, you never onboard the ACP log. Wait, you don't have the log from your domain controller, are too big, too expensive. So I want to point one-to-one to the machine and to the owner. And here is where IPFS got in. I mean, I was browsing in the weekend, absolutely not working. If my employees see me, they told me, you don't work in the weekend, so I'm never working the weekend. I work 8 hours a day. But when I was there with my computer, I saw this talk from Benet. Benet is the creator of IPFS. He's a super nice guy. You see him, and he speaks super simple about an incredible protocol. The project was started in 2015, and the idea from his side was to create a protocol that is fully distributed with a lot of amazing features that I see, and we will see during the talk, a match for us in security. But for him, the goal, it was about distributing web, avoid to have this big company like Google, Facebook, that own enormous data center, and be the next HTTP. You have to see it as a sort of BitTorrent for data. So you have on a side some BitTorrent protocol, and on a side a file system that distributed across the web. In the moment that I start to read about the documentation, I finished to understand that, I mean, this protocol could fit with the security industry, and we will see all the features. What is important to understand here is that IPFS is not a product, it's a protocol. So imagine that we are describing today what is happening in the 70s in terms of HTTP, DNS, and all the other protocols that are in. Now, to make a simplification, we have a 3-level of stack with 3-4 components that are really important. The first one you can see is libp2p. That's the network stack. How all the nodes communicate, how all the nodes speak to each other, and how the entire swarm of hosts are able to contain themselves and do their own routing. If you're going to play with it, you will not see this as much as if you write a web application, you don't have to deal with TCP. Then you have IPNS and IPLD. That's are used to define your data. We will get into the details of this. And this is how the entire protocol is using this to map your information across the swarm of hosts. On top, you have a series of libraries that can be used to define your data set. Because again, it's a protocol, it's not an application. Let's move to the node properties here. So you have your node, and your node is your endpoint. That's how I try to figure it out. Every node in the machine is a PKI-based identity. So you know that you have some key that identify your host uniquely across your infrastructure. Every host can be a client and a server, as in every shared infrastructure, and every node is independent. So you can start from a single node and expand your network across thousands and thousands of devices. Every node is going to automatic and auto-discovery, really similar to the BitTorrent logic. I didn't want to get inside all the technicality because we're near the lunchtime. I don't want to make you fall asleep. But you can embed application inside IPFS installed on the system. So if you want to run any other application on top of your data, it can run directly on the node. And everyone can become a server or a client. Now, we can clearly see the scalability that we can have compared to HTTP or any other protocol that we use for collecting log. You can start from 3 hosts or 100, and the system and the storage scale automatically for the number of hosts that you have. Let's explain how it works. So if you can see the slide here, imagine that is a web URL. The same is valid for your data. So every host is having its own naming convention. You have the description of how an host is working. So every host is having a series of modules that permit it to talk with each other. And every data that you see is hashed inside. So imagine that you have every chunk of your var log that you see is chunked in small pieces and hashed. Now, what happens is that on top of it, you need to get a naming convention to point it out. And that is called IPNS. So you have a lot of parallelism between the technology that we use today and the technology of the swarm. Now, in the moment that you see this, you go install and it works. But what is really interesting is about how the data is managed. The data that you're going to onboard in IPFS work really similar to Git. So every time that you have a log file, for example, the log file gets split in chunk, 256 kilobytes of chunk. Every chunk got hashed in a multi-hash format. So you have support for SHA-1, SHA-2, MD5, that MD4, okay, they're old protocol, but they're still supported. Every chunk of this data have a multi-hash. This multi-hash got integrated in the seed. Seed is a sort of pointer. And is a pointer that contains multi-hash. And the moment that you search across your swarm, you can see and you can search by hash. So imagine that you have your entire fleet and all these logs that are stored with a unique link. Imagine that you have an IOC, an indicator of compromise, and you want to search if you have any of these indicators across your fleet. You don't search for the string, you search for the hash. And the swarm is going to respond you back with all the hosts that contain this hash. The idea of the protocol was to distribute the load. But if we use this feature as a security feature, we can already identify in a single call all the hosts that contain compromisation. What is also nice is that all this copy of the file, you can distribute in how many copies you want across your device. So if you have this log and you want to move this log and commit it to the other host, you can have n copy of this log pointing out to this. And it's really similar to the commit. So you can see your log that is changing and growing with multiple hash pointing out to the previous version. And a one-to-one concept to a Git commit and a Git history. All of this, again, is running directly on the endpoint. Now, how you can point to a log of file if the log is defined by the hash. So it means that the file is changing every time. You cannot know where to point it out. And here is where IPNS is coming out. IPNS permit to point as a DNS link with a proper name to any file name and to all its history of hash. So, in the moment that you're going to define this in your infrastructure, you can point a link, like a DNS link, to your machine name, and then point a link to a log file, varlog Apache, to make it super simple. In the moment that you hold the DNS link, the swarm of IPFS is going to give you back all the history of log of this file. And in the moment that you get your history of log, you have the hash and the versioning of every string inside the file. Now, when IPFS was born, the idea was to distribute it across the world. People realized that you cannot make everything public. I mean, if you try to make everything public in your organization, it's going to be a problem. Probably you're not going to have a job. That's why there was a side project that was called IPFS clustering. Now, IPFS cluster is a way to create an internal network of IPFS inside your infrastructure. So, again, PKI-based, not exposed outside, and you can distribute across your fleet. The cluster is auto-regulating itself. You have already metrics and monitoring. And fundamentally, in the moment you deploy, you can add and remove host from it. You have both static cluster and dynamic cluster. So if you're imagining a situation where you want to monitor your log on your server fleet, you can define a static cluster of IPFS, and the static cluster is going to work by its own, pointing only to the machine that you select. Or you can define a dynamic cluster where you grant a key to access to the endpoint, and the endpoint can join or disjoin the cluster itself. Again, it supports the same feature as the general IPFS. You have the possibility to have a replication factor. That's a big problem when we are testing it for playing. You have a lot of machines that go up and down the cluster. So you want to have access to this log as well. You have a minimum replication factor in the configuration that say that every log needs to be copied to at least 1, 2, 3, 4 times across the cluster. So if they go offline, you still have access to your data. And you can list and remove peers. So I swapped the slide. Okay, so you have a series of commands that are pretty simple with API support to be able to access all the information in the cluster. If we go through this, you can see that you can have the ID of the cluster. You can go to see how many peers you have connected. So you can list all the machines that are active at the moment. Simple CLI command. All of this is API supported as well. You can remove an host because you don't consider a good host. You can add a single file for all the machine to be monitored in the cluster. So you decide that you're going to install your application, I don't know, a new web app. You want to monitor this file. You can tell to the entire of your fleet to add this file to the cluster so it can be accessible. You can also start it. Pinadd and pinrm is a way to put the file as always available. So you can decide to have a file that is going to duplicate it more. You can list all the files that you are monitoring and see the status on how much they change. You can sync and recover. Sync is a way to extract the file from the cluster, or you can recover a file that is in some error state and regenerate the hash of it. All of these is API have a full API support, so it can be simply automated. And upgrading and managing the cluster that probably someone here is thinking about is not problematic. So the upgrade of node is automatic. In the moment that you upgrade your master in the cluster, the master is automatically replicated in the update of version or request in the moment a new client join. In case the in case there is failure during the upgrade, the swarm automatically connect to the hosts that are near to find a possible state of work, so they are replicating. Now, to be transparent, IPFS clustering is top to scale at 1,000 hosts right now. So if you add more than 1,000 peers, the cluster is going down dramatically. We're going to see at the end how the guys that are working on that, they're improving it a lot. But it's still, again, a sort of work in progress. In terms of the security of the cluster is have a full API support, CLI support. There is no central server about it, so there is no master. The master is hereditated really similar to what was... Anyone remember how Skype was working at the start? With a sort of big master depending on the bandwidth and how it was stable? The concept is really similar. So you can confirm your own master, but in the moment that you lost it, another host with the best bandwidth and stability is taking the master as per se. There are permissions that you can set across the clusters, so you can say that certain client can add their own file and others can't, so it's fully configurable. You can say that they can modify the pinpoint, so the file that you're gonna save or not, and you can set automatically to update the PNS, so the DNS. In the moment that a system join, you can tell to the system to notify the PNS protocol, our DNS, to give the file name. And there is a lot of integration ready, so you can use Go, you can use JS or whatever to communicate with the cluster. There are libraries for everything. And then is about integration. So the integration that you're gonna have is like how I'm gonna integrate my SIEM solution across this new toy that I can install. Now, IPFS grants as per se a gateway. Is a web gateway that you can pull through your HTTP API, and you can make requests through the gateway to your swarm. So fundamentally, it's a matter to write a script that is going to request the file and put it where you want. If you want to integrate with that, you see that, for example, I think Cloudflare have a big gateway if you want to play with it that is publicly available to interact with IPFS. If you want to create by your own, it's like a 5-minute script to create these, and if anyone wants, they can share this script as well. You can play with React. So React have a really nice library to integrate with IPFS and both with IPFS cluster. You can use Brig. Brig is a new tool written in Go, and is a way to synchronize file across your swarm and the local container if you want to still use your CM. What I'm spending time with at the moment is with Minerva. Any one of you know Minerva? Nope? Okay. It's an Apache project to do a sort of data science across peer. It have a plugin for IPFS. It's SQL based, so you can connect Minerva to your IPFS cluster and run SQL query across your data set. And this transparently remove all the IPFS that we spoke before, and they see it as a pure file system to run a structured data query. At the moment, as again, nothing of this is in prod, is only pure research and playing. Minerva and the IPFS gateway, is the two tools that are more stable, at least in my opinion. What we see here is the short-term goal. Now, if you go to your IPFS, and here you understand the stability of the project. These are the goals from the project for the next 6 months. So the project is really active. There is a lot of commit and side project on it. I'm going to release a demo in few days on GitHub, if you follow it, and on how to make your security cluster working. There are some problem in terms of data sets. So if a single endpoint have more than 1 terabyte of data to share, it slow down a lot the query. They're gonna fix it in more or less 6 months. If your cluster is growing at more than 1,000 hosts, you start to hit a sort of We don't know which bike, but the performance, they seriously go down. And yeah, and the community is extremely active and supportive. So if you want to join this effort to bring it to the security side, you see a lot of people that are helping you to write any sort of script or extraction. And fundamentally, that's it. So, any question?
Any questions for Fabio?
Sorry, I don't know if you mentioned it, but what about encryption? Is there any?
Ah, yes. Yeah, you're right. Okay. So, data rest, data in transit, and everything is clearly fully encrypted. All the copy of your data reside in a small storage that you run in every endpoint is encrypted as well. All the communication are encrypted as well, and you have the, practically fully secured. And actually, consider you're running copy, and that's a really good question, I totally missed the point. All the data that are copied across node for replication, they are not accessible by the same node. So the node as per se, the endpoint of one of your employees don't have access to the data that is stored. You only see a blob of encryption running there. The only way to access this data is to have the key of the master or to have access to research, but you cannot access the local copy. I think they want to make.
Told something about performance issues, 1,000 peers.
So that's about my personal test. So we're running with FutureLeague and FriendEase. When we try to replicate across more than 1,000 endpoint, and I'm talking about in the scale of 1 to 10 gig of log each, touching the 1,000, the performance starts to decrease dramatically. Okay. As of today, the guys that are working, I'm not actively writing this code for the cluster, I'm only playing with it, but speaking with the community that is writing the cluster code, they say that they're gonna fix this issue in a few months. Both in terms of size, I never tried to hit the more than 1 tera data store per host, because the problem of logging never hit 1 tera per single host, but there is the same problem as well, but it should be fixed on a bigger scale.
Okay, also, for example, if you have 10 nodes and you have 1 terabyte, more than 1 terabyte, you also have performance?
Per host, not per endpoint, not per total share. That fundamentally, I mean, I don't have any case that it happens inside my career where a single host has more than 1 tera log to be accessed.
I see. Okay, thank you.
Any more questions?
Don't be shy,
We've got plenty of time still.